In this video, I will show you the text file handling and its different uses by using Python programming language. I divide the file handling topic in three different parts. In the first part, I will talk about on text file only. So what is a file? Files are named locations on disks to store related information. That means data stored in our permanent storage with some name, and it resides within some location. That's mean within C drive, D drive or E drive, or it may be located within some folder also. So that's why I have written like this: files are named locations on disk to store related information. Files are used to permanently store data in non-volatile memory, example hard disk. Files in Python are used to store the data that were input as well as the generated output permanently so that we can reuse it later. That's mean when a Python program executes, sometimes it requires some input. So that input can be supplied from a file also, and the file must exist within the permanent storage area. Now think in another way: when a Python program executes, it gives some output. So that output can be stored permanently within some file for the later use, because in some of the cases we require this output for later analysis or for reusing this output for the input of another program. Next, type of data files. So we will deal with two different data files, that is the text file and the binary file. So what is a text file? A text file consists of human readable characters which can be opened by any text editor. Each line of a text file is terminated by a special character called the end of line. These text files support ASCII and the Unicode. Suppose I have created a text file by using the Python programming language, but this file can be read from outside the Python programming language. It can be opened by any text editor like Notepad or Notepad++ or WordPad, etc. The another type of data file is the binary file. Binary files are made up of non-human readable character and symbols which require specific program to access its content. So when we create a binary file from within the Python programming language, and if you try to open this binary file from outside the Python programming language, you will see all sorts of scrambled character within the file, and it can't be opened through any text editor. It is of no use. So for that, if you want to see the content of the binary file, you require a specific application, or you require the application from where the binary file has been created. So in this video, I am not going into the deep details of the binary file. We will talk about text file only. In the next video, I will elaborate about the binary file. Now next, move to the next slide. File operation. What are the different types of file operations supported by the Python? So by using the Python programming language, we can open a file. Next, we can read or write a file. Then after read-write operation, we need to close the file. These three operations are common to any Python file handling program. Now let me show you how to open a file. For that, we require an open function. Open function is used to open a file, and this is the syntax of opening a file. So for that, we require a file object equal to, this is the inbuilt open function, and within the bracket we need to specify the file name. There is an alternative syntax: file object equal to open, the inbuilt function name open, within parenthesis the file name along with an access mode. This access mode means it specifies whether we want to read a file or write a file. So when we do not specify any access mode during opening a file, it will considered as a read mode. That means we are going to open a file for the reading purpose only. We cannot write at that time. And if I have to specify any other access mode other than read, then we have to write the access mode at the side of file name. The file object establishes a link between the program and the data file stored in the permanent storage. Suppose this is the memory of the computer, and think this is the permanent storage device, hard disk drive. Consider a program, say prog.py. Suppose this is a Python program, and within this Python program I have written some file handling code, and let me consider f as a file object. So file object f equal to open. Suppose I have opened a file whose name is abcd.txt. So abcd.txt is the file which is going to be created. Suppose this file contains some data. This will be stored right back to the hard disk later. And what the file object is doing, it is pointing to the file abcd.txt. This file object f establishes a link between the program and the data which is going to be stored within the permanent storage. You can think f as a pointer to the data file. Let me show you a complete statement of opening a file. Look, here file1 is the file object. You can give any name in place of file1. So this file1 object will points to the file which is mentioned within the open function. After that, here it is the open inbuilt function to open a file, and within the parenthesis, look, here is the file name. Record.txt is the file name, and this is a complete path, C:. Here I have written double slash. Why? Because if I write a single slash, then slash t and slash r represent some special meaning which is called the escape sequence. So to suppress the special meaning, we require an extra slash which has been written in front of the actual slash. That's mean if I write a single slash, then slash t will be considered as tab or the horizontal tab. So to suppress the meaning of tab, we require this extra slash. So whenever you write the path of a file name, then you have to specify double slash. So this is the path to file and this is the file name. So along with this path and the file name, we require the access mode. So here is the access mode. This R is the access mode. The character R over here represent the read mode. R represent the read mode. There are other access mode also which will be discussed in the next slide. Now look, if the data file here is the record.txt, if it exists or created within the location where the program file, that is the Python program file, is situated, in that case you do not have to specify the whole path, just write the file name only. That's mean when the Python program and the data file where the data is to be stored are residing in the same location or in the same folder, you do not have to specify any path, just write down the file name. Now if you want to write the same file name and the path name by using a single slash, there is a provision. Look, file object name equal to open, and within the parentheses the same file name along with the path is written, but this time I have written a single slash, and for that we require an extra R character in front of this double inverted comma. This R specify, the prefix R in front of the path makes it raw string, that means there is no special meaning to any character. So whenever we write an R in front of the path name, it will suppress all the special meaning within this path name and the file name. This time slash t and slash r will not be considered as any escape sequence, it is simply a string. And be very careful that the access mode and the path and file name will be enclosed within double inverted or the single inverted comma. So this is the technique of opening a file. So there are different access mode other than read also. So these are the access mode. So for R, this is the read only. If you write a W in place of R, that's mean it will consider as write only. During read mode, be sure that the file exists in your system. During write, a new file will be created for writing. Now if we specify A, it is considered as append. Append means it is also one type of write. If no file exists, it will create a new file, and if the file exists, then the data will be added at the end of the content of the existing file. So be very careful during append mode. If the file exists and the file contains some existing data, then the new data will be concatenated right after the existing data. So in case of append, the existing data and the new data both will be saved in the same file. Now if I write plus after R, that's mean along with the read, the file can also write also. So both read and write operation can be done on that file. If I write W then plus, it means along with the write we can also read the file also. A plus means A already means one kind of write. So along with this append we can also read the file also. Now let me tell you about the closing of file. So closing is a very important operation within a file handling. A close function breaks the link of the file object and the file on the disk. I have already shown you that how the file object establishes a link between the program and the data file. and this close function will help you to break the chain. So whenever you completed your file handling operation, just remove the file object from there by using the close function. The syntax of the close function is the file object name dot close and then the parentheses open and close. Closing a file will free up the resource that were tied with the file. This file object holds different information related to the file it is pointing to, and by closing a file, it will release all resources tied up with the file. Now, this method is not entirely safe. If an exception occurs when we are performing some operation within a file, the code exists without closing the file. Look, this close function has a different use, or it has a different utility. This close function helps to release the resources which are bind up that were tied with the file. It also helps you to save the file in the permanent storage properly. So when a close function is executed, we are assured that the file is saved properly. But look at the situation. Suppose you have a file like this and you have opened a file from here. Now you have some code, and at the very last line of your program there is the close function. What will happen if there is an exception occurs in between the open and the close? So when the program gets interrupted over here, the program will stop right from here. So whenever a Python program encounters an exception, the program terminates right over there. It will come out from the program, it will show you an error message, and it may happen the file is not saved properly. So in that case, the file maybe gets corrupted or it cannot be used later. So that's why I have said that this method is not entirely safe. Now, let me show you how to read the content of a text file. To read the content of a text file, Python provided you three functions. The first one is the read, then readline, then readlines. So I will show you the difference between all these three functions by an example. So let's start with the read method. Read method is used to read a specified number of bytes of data from a data file. So if I write some file object name, then dot read within bracket n, suppose n is 10, that means it will extract 10 characters from the file. So whenever file is open in a read or write mode, an invisible pointer, you can tell it as a file pointer, and it is located at the first character of the file. So whenever we specify read within bracket n or any integer value, it will extract that amount of character from that file. If no argument or a negative number is specified in read method, the entire file content is read. Let me show you an example. Before starting the program, let me show you where I am going to store my files, that is the data files. Look, so this is my computer or this computer, and within this computer I have 4 drives. So I have used the first drive, that is a C drive. So within the C drive there is a folder named as Python 37. This is the installation folder. I will save all my Python program as well as the data file within this folder. So let me open this Python 37. So within this Python 37, these are some system files, and look, this is a file Twinkle. This Twinkle is created by me. Let me open this file first. Look what it is written: twinkle twinkle little star, how I wonder what you are, up above the wall so I, like a diamond in the sky. So this is the first stanza of the well-known poem, I think you all know. So here are the 4 lines written within this file. Look, after twinkle twinkle little star, I have given an enter, then I have written how I wonder what you are, then again an enter. Up above the wall so high, again enter, like a diamond in the sky. At the last line also I have given an enter. So there is another line situated below this, like a diamond in the sky. Actually there are 4 lines, and I think that you all know that enter means a new line, that is slash n. So after every line there is a slash n. Now let me close this file or minimize this file. Now let's start writing the program. Look, the name of the file is Twinkle, and this is a txt file, and it is residing within this PC local C drive and within Python 37 folder. Now first create a new file. So here I will show you how to read the content of the twinkle.txt file. So reading file content of twinkle.txt file using read function. First of all, I have to write some file object name. Let me write it as f. So f is the file object name, then the open function, and the file name is twinkle.txt, and I have to open it as a read mode. If I do not specify any access mode, then it will be considered as read mode. But I will suggest you to write access mode always with the open function. First of all, let me save this file. Let's save the file within the same folder where the twinkle.txt is residing. So that is within this PC, within C drive, within Python 3.7. Let me give the file name, Python program file name, as file demo01. So file demo01 is my Python program name, and twinkle.txt is the data file from where we are going to read the content of the file. Now in the next line, after opening the file, I am printing f.read, the file name, then the read function. Look what happened. If I press F5 to run the file, look, it will extract all the lines or the content of the file. Now if I write say 5, run the program, look, twink, that's mean it will extract 5 characters from the beginning, that's mean twink. So if you specify any integer value within the read function, it will extract that number of characters from the file. Look, I have not written any .close function or the close function within my program. Still it is executing properly. Since the file is already saved properly, so you do not require that close function in case of reading a file. But still, I will suggest you to write the fclose function whether you read or write a file. So make it a habit of writing close function within your program. If you do not write the close function, the problem arises during the write operation. Now if I write say 50, that's mean it will extract 50 characters from the file twinkle.txt. So you have to count the character like this, twinkle, that's mean 1 2 3 4 5 6 7. The space will be counted as 8, then 9 10 11 12 and so on. You have to also count the enter. After star there is an enter, so we have to consider this enter within our count. So all tab, space, white space character, everything will be considered as a character, and you have to count each and every character. Next, reading the content of a text file using the readline method or the function. Look at these points. Readline reads one complete line from a file, where each line terminates with a new line, that is /n character. It can also be used to read a specific number n of bytes of data from a file, but maximum up to the new line character. If no argument or a negative number is specified, it reads the complete line and return strings. Let's explain each and every point by showing an example. Before start writing the program, let's take the same data file, that is twinkle.txt. Let me open it and show you what is the content. So the first stanza of the poem Twinkle Twinkle Little Star, so 4 lines are written over there. So we are going to read this content by using the readline function. So let me close it. So this twinkle.txt data file is residing in the same location where my program is residing, that is within this PC, local drive C, and within the folder Python 3.7. So both the program and the data file are present in the same directory. Now look, first of all, let me create a file object f. Now we are going to open this file in the read access mode. Now if I print f.readline say 10, then the file must be closed by using the close function. Save the file. Look at the output. So when I'm writing 10 within this readline function, so it is showing the first 10 character of the data file. T, this is the first character, 1 2 3 4 5 6 7. Space will be counted once, so 8, then 9, then 10. So there are 10 characters in the output. You can think that it is behaving like a read function. So look at the second point. It can also be used to read a specific number n of bytes of data from a file, but maximum up to the new line character. So the example here I have shown you is the second point. So whenever you are specifying the number of characters within the readline function, so it will extract that number of character from the content. But look, if I write 50 over here, now run the program, look, it will extract only the first line. It will never extract the 50 character from the data file. If you do not specify anything within the readline function, still then also it will extract the first line of the data file. So readline function extract data up to the /n, that is up to the new line character. In a simple way, readline function extract a single line. So whenever you specify a number which is less than the length of the line in the data file, it will extract that number of character and display it into the console. So for that, the first line, readline, reads one complete line from a file where each line terminates with a new line character. And also look at the third line. If no argument or a negative number is specified, it reads a complete line and returns string. Now let me show you that without using the readline function, we can extract each line from the data file by using a for loop statement. So let me erase this line. In place of it, let me write for line in file object name, that is f. Within this, let me print the line. After that, f.close will remain same. Now let me run the program. So look at the output. It is showing twinkle twinkle little star, the first line, and since there is an enter or a new line or /n at the end of this line, so for that it is leaving a space in between these two lines. Then how I wonder what you are, then again a /n is there, so for that a blank line is showing. Then the third line, then again a blank line, and at last the last line. Since there exists a /n at the end of the last line, so there is also a blank line at the end of the last line also. Now we can do the same thing by using the while loop. Let me show you an example for that. So after opening this file, let me write str equal to f.readline, then parenthesis, so it will extract the first line. Now while str. Now if the str contains something, obviously in the above line, when f.readline execute, it will read the first line and store within str. So str has something, that's mean it's not null. So while loop will satisfy and the control will enter into the loop, and there we will print the value of str, so it will print the first line. And in the second line, initialize the same variable str with f.readline. So here what is happening, so when again f.readline is executing, it will read the second line and store within str. Then the control will again move back to the while line. There it will found that str has something this time also. So str contains the second line, it will enter into the loop, it will print the second line. Then again f.readline, it extracts the third line, it reads the third line. So again loop will continue, str has the third line, so it will enter into the loop and print the third line. Then it will read the fourth line and store within str. This time also str has something, so the while loop satisfy and enter into the loop, it will print the fourth line. Now after reading the fourth line, when again f.readline will execute, it gets nothing. That's mean nothing to read, because the file pointer reaches at the end of the file, so there are no more character or line to read, and for that str will be initialized with null. After that, when while loop is again encountered, it finds that str has nothing, so str is null, which represent false. So when the while loop become false, the control will come out from the while loop, and then the file is closed using the close function. So let me save and run the file. Same thing is happening, all 4 lines are displayed and there is a blank line in between each of the line. Next, move to reading the content of a text file using the readlines method. So here is a s at the end of readline. So readlines method, the method reads all the lines and return the lines along with a new line as a list of string. That's mean by using these readlines, we can fetch all the line from the data file, and all these lines are stored within a list. Suppose this is a data file, say abc.txt, and it has line 1, line 2, line 3, and each of the line has a /n at its end. That means there is an enter after each line. When we extract or read the content of this data file by using the read lines, it will create a list, and each line will become the individual element of this list. That means it will look like this. So line 1 will be the first element along with a /n, then line 2, then /n, then line 3, /n. So each line will become an individual element of a list, and each and every element has a /n at its prefix. So the list will look like this. Let me show you an example. First of all, let me open the file, say f equal to open, within it twinkle.txt. Let the access mode be blank, nothing to write. Now if I print f.readlines, then f.close, look at the output. So it is showing the content of the file. Look, the first line, twinkle twinkle little star, then a /n, because there is an enter or a new line at the end of this line. So this is the first element of the list, that is the line. Each and every line becomes an individual element of this list. Look at the second element. This is the second line. How I wonder what you are. There is again a /n. Up above the wall so high, again a /n. Then like a diamond in the sky, again a /n. Now if you do not give any enter at the end of the last line, then this /n, the last /n, will not be displayed. Now let me show you how to calculate the number of words in a data file. Suppose this is the content of our data file. So the first 4 lines of the twinkle twinkle little star. So now we are going to find out how many words are present within this file. So after opening this twinkle.txt, initialize a counter variable with 0. Let's write a for loop for line in f.readlines. That's mean f.readlines returns a list which contains each and every line along with a /n, and this line will read each and every line one by one. Within this loop, let's write words equal to line.split. I think you know about the split function. It split a line of text with respect to space. Now this line will be initialized with the first element of the list that is written by f.readlines. That means line will be initialized with the first line, that is twinkle twinkle little star /n. Now within the for loop, this line will be splitted up with respect to space, and the new word list will be formed. This word is also become a list which contains each and every word as an individual element of the list word. I will show you the dry run later. Let me complete the program first. Let me print the word so that you can understand what the word list is containing. Then increment the counter variable c with the len of what? Sorry, it will be plus equal to. So c plus equal to, that means c equal to c plus len of word. Now after coming out from the loop, let me close the function, and after that let me print the total number of words equal to c. Now let me run the program. Look what happened. So first it will extract the first line, that is a twinkle twinkle little star, and it breaks the line into an individual word and storing it into the word list. And when the word list is printed, look, twinkle, then little, then star. So the lines are splitted up with respect to space, and it forms a list which is stored within this word variable. So when we are printing the word variable, it is printing the corresponding list. Now in the next line, it is finding the length of the word. So the length of the first word list is 1, 2, 3, 4. There are 4 words. Twinkle twinkle little star. There are 4 words. So 4 will be initialized within C. Now again the for loop will execute. It will now read the second line. The second line will be splitted up and stored within the word. So look at the word in the second execution, it will look like this: how I wonder what you are. So the how I wonder what you are splitted up into an individual word, and the word list is look like this. Now when again its length is calculated, so there are 1 2 3 4 5 6 words are there within how I wonder what you are. These 6 will be added up with the previous value of C, that is 4, so 10 will be again initialized within C. So in the same way it will extract each and every line, split it up every line to words, and calculate the number of words and stored within C variable. After coming out from the for loop, it will display the number of words present within the file, that is C, and here its value is 22. Now next come writing onto files. So there are two methods for writing data into the file, that is the write function and writeline function. First I will discuss you about the write function. Look, here I have written some points regarding this write function. Write method takes a string as an argument and write it to the text file. So whatever the string you are supplying within this write parenthesis, it will write onto the file specified by you. It returns the number of characters being written on a single execution of write method. So write method returns number of character that is written into the file. We need to add a new line character, that is /n, at the end of every sentence to mark the end of the line. So write function cannot add a /n or a new line implicitly. So we have to do this separately. Let me show you an example. First of all, let me create a file object f, then open function, then student.dat, because it is a data file, so I'm writing dat. You can also write txt, so it will represent a text file. Let it be student.txt. Now this time we are opening this file by using w access mode, that is the write access mode. Since we are going to write something within this file, for that we need to write w in place of access mode. Now in the next line, let me take some input from the user. So input, enter any string, then by using the file object, let me call the write function, and the parameter will be s. Since write function do not add /n implicitly, so we have to add separately this /n along with the input string. So here we are concatenating input string and the /n, then this will be written onto the file student.txt. We can also write C equal to, so that we can display how many characters it's stored within the file. So C will store how many characters are written within the file. If you do not want to display that figure, then you do not need to write like this. Just simply write down f.write. So in the next line, let me close the function. Now print number of characters equal to C. So it will display the number of characters written within the file. Now the file is saved properly. Now let me display the content of the file right from this program. So for that, let's print reading the content of the file. Then again we have to open the file student.txt using the read mode. Now let's print the content of the file using the read function. So read function will read the entire content of the file. Then again we have to close the function. Now look at the output. It is showing enter any string. Suppose I'm writing ABCD. So it has a 5 character. Why? ABCD, this 4 character along with a /n. Since it is considering /n along with ABCD, the input value, so it is showing 5 characters in the output. So look, when it reads the same file, it is showing ABCD. Since there is a /n at the end of this string, so it is showing a blank line after ABCD. Look, this file student has been created within the same folder where the program is residing. Let me open it. Look, here is ABCD, and due to /n, it contains a new line. The another function for writing onto the files is the writelines. So these writeline functions will write multiple lines at a time within a file. So writelines method is used to write multiple strings to a file. We need to pass an iterable object like list, tuple, etc. containing string to the writelines method. Unlike write, the writelines method does not return the number of characters written in the file. So writelines method do not return anything. And before writing data into the data file by using the writelines method, we have to store the multiple string within some list or tuple. Then this list tuple will be passed as an writelines argument. Let me show you an example. First of all, we have to open a file using write mode. We are using the same text file student.txt and it is opening in a write mode. Now after that, let's create a blank list. Within a loop for I in range 3, suppose I want to take 3 lines at a time, or we want to accept 3 strings from the user. For that I'm writing for I in range 3. Within this, let me print the I plus 1. Next, name is a variable where we are going to take the input. So it will accept the first string and this string will be append within the list L. So it will be name, and along with name, let me concatenate this /n because writelines do not add /n implicitly. Now look what happened. When the value of I is 0, it will display enter string 1. It will take a string as an input from the user and store within name. So this name will be append to the blank list L. Now again the loop will continue. For I equal to 1, it will take another input from user and that will be again stored within the list L. So in this way, the list will be filled up with 3 strings. Now come out from the loop and let me write f dot writelines, and within the parentheses there will be L. After that f dot close. Now let me again print the content of the file. For that I have to again open the file, that is student.txt in the read mode. Since there are multiple lines within the file, so for that I have to again run a for loop. So for s in f, let's print s, and after that f dot close. Let me run the file. Now it will asking for the first string. Suppose I am writing Tim. Again it is asking for the second string. Suppose I am writing K. Now the third string, say Amy. Now look at the output. So when it again read the content of the file, so it is showing Tim, K and Amy, and since there is a /n after each string, so it leaves a blank space after each line. Now opening files using with clause. To open a file in read or write mode, we can use with clause. First of all, let me show you the syntax. Look, so when we are going to open a file using with clause, we have to write like this: with, this is a keyword, then open function, same as traditional approach, then within the parentheses the file name, then the access mode, as, this is also a keyword, then any file object name, and all the file operation whatever we need to do are to be done under this with clause. For that we have to maintain an indentation under this with clause, and we have to write all the file related operation under this. The operation is completely same as before. It is a different approach of opening a file. But there is a difference between the traditional approach and by using the with clause. The advantage of using with clause is that any file that is opened using this clause is closed automatically once the control comes outside the with clause. That means we do not have to write file object dot close function to close a file. So this is the difference. Let me show you an example. Let's write like this: with open within bracket, let's open a file named as twinkle.txt. Let me show you that file within the folder. So here is the twinkle.txt. Let me open it first. Twinkle twinkle little star rhymes are written over here. Now let me minimize it, and it is resides within C drive, then Python 3.7 folder. Within this Python 3.7 folder, my program file, file demo 01 and the twinkle.txt, the data file, both are present at the same location. Now look, then we have to write the access mode. Let's write A. A means append mode, as if. Suppose I want to add the name of the author within the file. For that, let me declare a variable, say author, and /n, then Jane Taylor. Jane Taylor is the author of Twinkle Twinkle Little Star, and I want to add this name at the end of the lines which are already present. So a /n in front of Jane Taylor means it will leave a blank line, then it will print Jane Taylor. Now f.write, then the variable name author. So the content of the author variable will be written within the file f, that is twinkle.txt. Now we do not have to close this file, because when we use a with clause, the file is automatically closed when the control come out from the with clause. Now again, let me open the same file twinkle.txt using a read mode, as f. Now if I print f.read, so it will display the entire content of the file. Let's save and execute the program. Look, the first 4 lines of the Twinkle Twinkle Little Star, then a blank line. So this /n is responsible for this blank line, then the author name Jane Taylor. So this is the technique you can use for opening a file by using the with clause. Next, I will show you about the absolute and the relative path used in file handling program. When we mention the complete path where my data file is residing, then we called it as an absolute path. I will explain this absolute path and the relative path by showing you an example. Before start writing the program, let me create a folder within C drive. Then here Python 3.7 is my installation, Python installation directory. Let me open this folder, Python 3.7. So let's create a folder over here, and let the name of the folder be, say, my folder. My folder is the directory or the folder created within Python 3.7 folder, which is under C directory. So when we enter into the my folder, look at the path. Let me click on over here. So C:/Python 3.7/my folder. So this is a complete path. And if I mention this path in front of the data file name, then it is called absolute addressing. Both the folder, my folder, and the file demo01, both are residing at the same location, that is within the Python 3.7 directory. First of all, let me show you an example of absolute path. Let's open the file with the with clause that I have shown you just now. So with open within bracket. Remember, the folder, my folder, is within C:/Python 3.7, and then I am going to write the newly created folder name, that is my folder. And within this my folder, I want to create a text file, say abc.txt, as write mode, then as f. So in this program, we are going to create abc.txt text file within my folder, which is residing within Python 3.7 folder, again which is resides within the C directory. / is used to suppress the special meaning for the escape sequence. So everything within the quotation will be treated as a simple raw string. Since here I have mentioned the complete path where the abc.txt will be created, so this is called absolute addressing. Now within this with clause, let me write something within this file, say example of absolute addressing, or you can say absolute path. Better to write absolute path. Now come to the relative paths. Look very carefully. The program file here, the file demo01, and the folder where the data file is residing, both are situated in a same location, that is within Python 3.7 directory. So my folder and file demo01 both are situated within the same directory, Python 3.7. Now when the program file and the folder which contains the data file, if they are residing at the same place, then the relative path concept can be applied. If my folder is situated within some other folder or in some other drive, so we cannot apply relative path. So be very careful that the relative path can be applied if the program file and the folder is residing at the same place. Now come to the program. We are going to open the file in the read mode by using the relative path. So here I am showing you the relative path, example of relative path. Now I am going to open the same file abc.txt by using the relative path concept, because my folder is present along with this program file. So for that we have to write like this. Just start with a dot, then double slash, then simply write the folder name, that is my folder. We do not have to specify where the my folder is residing. Then abc.txt, and this time we are opening the file in the read mode, so the access mode will be R. Now if I print f.read, so it will read the entire content of the file. Let me run the file first. Look, when the above two lines are executed, so it creates a file abc.txt within the my folder directory, and it has written this line example of absolute path within that file. Now by using the relative path concept, we access the file in the read mode and we display the content of that file. This is all for absolute and relative path. Next, the flush function. When writing onto a file using any of the write function, Python holds everything to write in the file in buffer and pushes it onto actual file on storage device a later time. Let me explain this point by showing you a diagram. Suppose this is the memory of the computer, and consider this file demo is our program file, and the program file contains some file handling code. Obviously there will be an open function which will open a file, and that file will be pointed by some file object variable. Here suppose it is f, and after certain operations or a number of lines, the file is closed by using the close function. And suppose this is our text file or the data file, which is pointed by the file pointer variable f. Now whatever the data we are going to write within this file, it does not go directly from the program file to the data file. So during write operation, Python generates a temporary memory location which is called buffer. So whatever the data needs to store within the data file are initially stored within the buffer first. This buffer is nothing but a temporary memory location which holds the data which are coming from the program file, and then it forwards the data to the data file. Think like that. Suppose your teacher is giving dictation in your class. You cannot write as fast as your teacher is dictating. So there is a speed mismatch between the delivery of speech from your teacher and the speed of your writing. So in that case, we hold some of the speeches in our memory, retain it for temporary basis. After writing it down in the copy, we forget the previous speech. The same thing is happening in this case also. The buffer is accepting data from the program file. It stored temporarily, forward the message, then it deletes the previous content from the buffer. When the buffer again gets empty, it will again start accepting data from the program file. Then again it is forwarded to the data file. So this is a continuous process, and it happens during the write operation during file handling program in Python. Sometimes it happens that some data within the buffer fail to go inside the data file. But when the close function is executed, all the data which are still residing within the buffer will be flushed out to the data file, and nothing will be left within the buffer. That's mean close function not only release the resources that are holding during the data file, it also ensures that all the data which are coming from the program file are saved within the data file properly and consistently. And it also ensures that no data left within the buffer. But what will happen if the program encounters some exception or error before reaching the close function? So in that case, if the program encounters any type of exception or error in between the opening of a file and a closing of a file, then the generated file may get corrupted or it cannot be used afterward. So for that we require a flush function. So this flush function of Python flush out all the data which is present currently within the buffer. and it saved those data into the data file properly. So I will suggest you, after each and every write operation, write this flush function. And this flush function is very important if the close function is far away from the write operation. Let me show you an example for that. Let's start with use of flush function. Let me open a file, say flushdemo.txt. Let me save this file within the my folder that I've created just now, and I'm writing it by using a relative path addressing. Since I've used a single slash, for that I require a R in front of it, so it will be treated as a raw string. Now f.write, this line has been flushed into the file. Then /n, let's write the flush function f.flush. Now again I'm writing f.write, and within this line may still be pending to be written onto disk. Suppose you have more lines over here within the code, and after that f.close function to close the file. Then again open the file in the read mode so that we can see the content of the file. This line, this flush function, ensures that the above line is saved within the data file properly. And since there is no flush function after this write, and the code may have more than one line over here, and if the code gets disturbed or interrupted by any reason, then this line may not saved within the file. But if the control reaches to f.close, that means everything goes right. Now if I run the program, you will get nothing difference in the output. All that I have discussed you are internal. You cannot see anything remarkable in the output. The lines has been saved properly within the file, and that are displayed by using the fread function, which are written in the last two lines of the code. The flush function forces the writing of data on disk still pending in output buffer. Flush function is implicitly called by the close function. When the close function is encountered, it automatically calls the flush function. Now let's move to setting offset in a file. If we want to access the data in a random fashion, then Python gives us two functions, that is seek and tell, to do so. Look what the tell and seek function do. The tell function returns an integer that specifies the current position of the object in the file. Or you can say in other words that it returns the number of bytes it traversed from the beginning. So here is the syntax, the file object name dot tell parenthesis open close. So you can find out the current position of a file by using the tell function. And what is about the seek function? Look, a seek function is used to position the file object at a particular position in a file. So when you require to position the file pointer to some particular position within the file, we require this seek function. Look at the syntax of seek function, the file object name, then seek function. Within parentheses, it accepts two arguments, the offset and the reference value. Offset is the number of bytes by which the file object is to be moved. Reference point indicates the starting position of the file object. That is, with reference to which position the offset has to be counted. It can be any one of these reference value, 0, 1 or 2, the beginning of the file, default, current position of the file, or the end of the file. It will be better understood if I show you an example first. First of all, let me create a file. For that we need to use the open function. Then within my folder, the newly created file will be, say, offsetdemo.txt, and it is open in read and write, that is W+. Plus means we can also read this file. So both read and write operation can be performed on this offsetdemo.txt file, which is residing within my folder. Now within this file, let me write two lines. The first line is like this, say good day /n. This /n is for the new line. Then again another line, say I like Python. Again there is a /n at the end of this line. So the file offsetdemo.txt contains two lines, good day and I like Python. After this write statement, let me print f.tell. So I want to know the current position of the file pointer. Since I didn't close the file, that means the file pointer is pointing at the end of the file. That is, it is pointing the end of these two lines, good day and I like Python. So after how many characters the file pointer is pointing now? So count how many characters. G1, O2, 3, 4. This space will be counted once. That's mean 5. So 1, 2, 3, 4, 5, 6, 7, 8. This slash n will be counted twice for slash as well as for n. Those slash n are treated as single character, which is called enter or a new line. Still, the tell function count these slash n twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 characters in the first line. Then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there are 25 characters in these two lines in total. So if I run this program, look what happened. It will print 25. That's mean the file pointer is pointing after the 25 characters. Now this time, if I read the file, the entire content of the file, so no displayed will be in the output. Why? Because the file pointer is pointing at the end. So from end, it can't read anything. Now we want to move back this file pointer at the beginning of the file without closing the file. So for that we require the seek function. So if I write f seek and within bracket if I write 0, look, 0 means beginning of the file. So whenever we mention a single parameter within the seek function, you can consider it as a reference value. So that is the beginning of the file and it is default. Now after the seek function, if I again read the file, then it will display the entire content of the file. That is good day I like Python. Now look what happened when I write f.seek 1, 0 and if I then print f.tell. So here 1 is the offset value and 0 is the reference value. So now look at the output. It gives 1. Why? Because from the beginning of the file pointer has been shifted to 1 position. So whenever we are calling the tell function, it is returning 1 because the current position of the file pointer is at the second position, that is over O. That means the file pointer has been traversed a single character. Now again, if I write 5 over here, then f.tell will display 5. That means file pointer has traversed 5 location and it is now residing at D. Now whenever I write print f.read, look, so it will start display from day. day/n, I like Python /n. day/n means a new line, I like Python. So f.seek 5, 0 means from the beginning of the file pointer has shifted 5 places and it is residing at 6th position. So it traverses the first 5 position and it is pointing to the 6th position. So that's why it is printing from day onward. And ftell function always return how many character the file pointer has passed away or traversed. So whenever you open a file in a read mode, the file pointer always starts from the beginning, and if you want to move the file pointer at the end of the file, so you have to write like this, file pointer name dot seek and within bracket you have to write 2. So 2 means end of the file. And if you have to continue some operation from the current position, for that we require the reference value as 1. So this is all for this video. I will show you different example in separate videos. If you have any problem, feel free to write me. I will reply you back as soon as possible. Thank you.